In this lecture, I will explain you the basics of electric potential. What is electric potential? Okay. Let us take an example. Suppose this is a ground, right? And this is a ball. Okay. I'm saying it. This is a ball and this is a ground. Okay. Suppose I am just what you say, I'm just rolling this ball upwards. Okay, so let us say I'm just throwing this ball upwards. So now the position of the ball is this one, right? But now what is the difference between this position, and this position? So the difference is, when the ball is at ground, there is no height. The potential energy equals to basically 0. There is no height. Okay, but when it attains a height, this is now height h. So when it attains a height, then potential energy equals to mgh. Okay, so this is the potential energy, or I can say this is basically gravitational potential energy, right? Now the second thing, suppose it is a ground again. Let me just do it like this, and this is a ground again. Okay, now what I am doing, there is a block of mass m. Okay, there is a block and there is a mass m. Okay, and it is attached with a elastic like this. Okay, now I am just saying it is elastic. Now what I must do, I need to pull this box like here, till like here. So what I am doing is I'm just pulling this box. So this box is moving now and it attains this position. Okay, and now when I'm pulling this, that means the elastic is basically stretched and it becomes like this. Okay, let me make the elastic like this so that you understand. So this is stretched and basically the box is moved. Okay, so now what do you say? This is basically elastic potential energy. Okay, so I have told you this is the gravitational potential energy and this one is elastic potential energy. Now that means what is basically the potential energy? What is potential energy? So basically you don't need to remember the definition. So what we are doing is, in this case gravity is in this direction, right? But we are working in this direction, opposite to the gravity. In this case, basically elastic like this, but we are working against, we are just moving. Okay, so basically the work done against, yes, so basically work done against, in this case it is a work done against gravity. Okay, and in this case the work done against elastic field. Okay, so anything which is basically electric potential is anything, the work done which is against that field, that is basically the electric potential. Okay, now I will explain you in terms of electric potential only. It will be more clear to you. Electric potential. Okay, so suppose there are two rods. This one is the first rod. Sorry. So this is the first rod and this is the second rod. Okay, these are the two rods, and in this first rod there is a positive charge and there is a negative charge here. Okay, so what is the potential energy? Like this, right? this one. So I always told you potential and the electric field. What is the direction of electric field? Always remember, it is always positive to negative. This is the direction of the electric field. Please remember. Okay. So this I mentioned, it is electric field. Okay. Positive to negative. Now suppose this is negative here, this is negative plate, and it has basically positive charges also, and this positive plate has negative charges also. Okay, so basically what will happen, I'm just writing so you understand. If I am moving negative charge, okay, that means I will move along the electric field. Okay, but we know, but I explained to you now, electric potential or potential basically is the work done against the field, right? Against the field, like in the previous example we did with the elastic and we did with the gravity, right? So look here, if basically this is negative, this side is negative, and if we are moving this negative charge from here to here, that means we are moving along the electric field. That means there is no work done. Okay, but if I am moving any positive charge from here to here, okay, I am moving the positive charge, then I can say my movement is opposite to the electric field. Electric movement is this direction, right? Electric field, but I am moving in this direction, so my movement is in opposite the electric field. So see, if I am moving negative charge, that means I will move along the electric field. But I explained to you electric potential is the work done against the field. So that is why we always consider positive charge. Okay, we like you always see the numericals. Suppose there is a positive charge here, there is a positive charge, we are moving this positive charge from here to here. We don't say negative charge, we always say positive charge. Now you understand why the positive charge, because we are moving against the electric field. Okay, so that's why we always consider the positive charge. That is, so I moved positive charge against the field. Okay, and potential energy is stored. Okay, and you all know SI unit of potential energy will be in joules. Okay, so I'm just writing the definition. What is electric potential? Work done in moving a unit positive charge against the electric field. Okay, so there you don't need to remember this definition. You can see we are doing the work done. I told you work done in moving a unit positive charge, because we are moving the positive charge, not the negative charge, and we are working against the electric field. Okay, remember, there is no work done if we are moving in the electric field. We are moving against the electric field, so work done in moving a unit positive charge against the electric field is stored as energy, which is called electric potential. Okay, so this is the definition of electric potential. Okay, I hope the potential is clear to you. Now the second theory is, what is potential difference? You definitely have heard this term, but what is this potential difference now? So what is the potential difference? Again, I am just explaining you with the help of the rods. Okay, wait, let me just copy this now. So I'm just making two rods now. One, see, it will not come right. My hands are like, can't draw the straight lines. Okay, please just think these are the straight rods. Okay, so these are the two rods. Hey, why I'm not able to make it? Wait, let me make it like this. Okay, this is the one rod and this is the another rod. Okay, now it's better. So I explained you, I'm just doing the positive charge here and I'm doing the negative charge here. Okay, one is positive, one is negative, and where will be the electric field? Always remember, positive to negative. So this is my electric field here. Okay, this is clear. Now let us suppose at point A, positive charge has electric potential energy. Okay, now electric potential energy is, potential energy is denoted by U. Okay, so let us suppose this is the positive charge which is moving. Okay, which is moving from here. Okay, the positive charge is moving, and let us say this point is A. Let us say this point is A. Okay, and we are moving this positive charge from here to this point. Okay, from this to this point, and let us say this point is B, and this charge is moved. This is positive charge here, this charge is moved, and let us say the potential energy at this point is UA and the potential energy at this point is UB. As simple as this. Okay, that means we are moving a positive charge from one position to another position. So let us say UA is the potential energy at point A and UB is the potential energy at point B. Okay, so basically the difference between the electric potential energy, basically it is the difference between the electric potential energy. Okay, so now what is the potential difference? Definition of potential difference: work done in moving a unit positive charge from one point to another. To another point, and where are the points? In an electric field. Okay, is called potential difference. Okay, so you need to know the difference, the definition of the potential difference and the definition of electric potential. So remember, when I am talking about potential, it's simple. We are just moving the positive charge against the electric field. Okay, this is potential. And what is the potential difference? When we are moving that positive charge from one point to another point in the electric field. Okay, this is called potential difference. So I am just marking. So this is the definition of potential difference, and This is the definition of electric potential. You must remember the two definitions, very important from examination point of view. Okay. And also let us take the another example also. Suppose there is a ground, to explain you more better. So it is a ground, right? And there is a ball at height h. The ball is here at this height. Okay. And I need, so let us say this is h1 and I need to change its position. Let us say I am just moving this ball from this to here. Let us say now the ball is attaining this position and the ball is attaining height h2. Okay, this is the ground. Okay, so always remember, at ground height is 0. That means potential energy equals to mgh, it will be 0. But at height it will be a difference. Okay, so I am just writing this another example. Suppose there is a body at height h1 from the ground, has some potential energy stored in it. Now we are doing work. We are doing work and moving it to another place, having height h2. Okay, so the work done in moving an object from one point to another point is called potential difference. Okay, so I hope the potential difference in electric potential is clear to you, and now I will write the mathematical expressions of these things. Okay, so basically what will be the mathematical expression? Potential difference equals to work done over unit charge. Okay, that means W over Q. Okay, or I can write delta V equals to W over Q. Why I have written delta V? Because it's a difference of 2. Okay, so this is the mathematical expressions of potential difference. That means the work done per unit charge. Now, because it is delta V, and delta V I explained to you, it is the difference between two. So can I say it is VB minus VA or V2 minus V1, anything. And work done is the basically the potential energy, delta U over Q. So I can write W equals to delta U is equal to the work done, which is bringing change in potential energy. Because when we are doing work, that means our potential energy is also changing because our height is also changing, right? So I can say VB minus VA equals to delta U over Q. Or can I write it VB minus VA, because I am writing delta U, then means I can write UB minus UA over Q. Can I write it like this? So this is my potential difference. Okay, I can say this is my potential difference. And what will be the SI unit of potential difference? Can you tell me? Yes. So energy is joule. So UB minus UA will be joule and Q will be coulomb. So joule per coulomb. Or I can say simple volts. Okay. So this is the SI unit. So I hope you understand what is the definition of electric potential, what is potential difference, and what is the SI unit of potential difference. So these things you need to remember. Thank you.